Hi, I'm Chad Lawson. This is a 3D printed fidget spinner, and you're watching Verbose mode. Welcome to Verbose Mode. I'm Chad Lawson. This is the podcast dedicated to learning to learn and the freedom to fail. Today I wanted to talk about 3D printing, and I'm going to start off with where I started most of my time with 3D printing, with fidget spinners. If you haven't seen these things, they're of course everywhere. For example, I recently had a client in Chicago, and just on my walk from the train to the client, I passed several different places that were selling fidget spinners, and I just thought, well, this is just getting out of control. Love them or hate them, they are pretty much ubiquitous. This is a fidget spinner that was purchased by a 15-year-old I know. Specifically, I am in Big Brothers Big Sisters. My little brother, my mentee, if you will, bought a fidget spinner online, saved up his money, and went to Amazon and bought I think it was like a $10, I think he said, fidget spinner. And in the meantime, as he told me that this was coming, I thought I had just purchased a PrinterBot Play, a 3D printer with a fairly small print bed. It's 4 by 4 by I think 6 high is the maximum print volume. And so I thought if he's going to be getting one of these, I might want to try to make one of my own. And even before I'd gotten mine printed, he contacted me to let me know when we saw each other at the next outing that a friend of his had borrowed it. I'm going to switch to the overhead. A friend of his had picked it up and played with it for a whopping 30, 40 seconds and dropped it. And as you can see, just absolutely completely sheared off one of the sides. Also cracked one of the other places such that it wouldn't hold the bearings anymore. You can see the bearings have all been removed, and that's because at our next time for an outing, I had him come over and said we could 3D print him a new one. I wanted to show him off this type of technology. So we started off by going to a website called Thingiverse, and I just simply typed in fidget spinner. And as you can see, there are just dozens and dozens of different styles and concepts for fidget spinners. Eventually we settled on one called Fidget Tri-Spinner. It had this neat little circular pattern, this hook-like pattern that he really enjoyed. So we went ahead and downloaded the pattern and printed one off. It ended up taking, I think, the better part of 2 hours to print. So that was 2 hours we sat there and talked while it was printing, and so it was really kind of a nice opportunity just to sit and talk with him. We ended up then taking his damaged fidget spinner and cracking out the bearings and then inserting them into the pattern you just saw. In the meantime, before we'd actually gotten together, I went ahead and printed this. I printed my own fidget spinner using one of the patterns I found on Thingiverse. This one presented me with a little bit of a challenge. I'm just trying to find the correct end. Here we go. You can somewhat see in this view that this side is much more thin. It kind of tapers here than this side. Luckily, that's the only one. But what happened was when I was printing, I didn't know the cause at the time, but the end had started to peel up on the edge closest to the outside of the 3D printer. It had started to peel up, and so as it was printing some of those lower layers, they were kind of pushing up, and it ended up warping the print slightly. I ended up then going back and printing it again with a lighter filament, using some different techniques to keep the print on the bed. And this one came out better. I don't have the same kind of distortions. So the skate bearings I was able to buy on Amazon, a 10-pack for $3, I think, $5, something like that. And the ball bearings in this particular size, a 10-pack for also like $4 or $5. So I was able to make multiple fidget spinners for not a lot of money. I will have in the show notes what the total then amount of filament that ended up costing. You can buy filament for a kilogram filament spool for roughly $25, $30, and I think that's what mine cost. So, and there's some calculations you can do. My 3D printing software will let me know how much cubic millimeters it was using, but that doesn't tell me the weight. And since I'm buying by kilogram, I should know how much I'm spending. So I'll look it up. But my total to make one of these, once you divide up the once you divide up the bearings and the filament, I think my total cost for each one of these ended up being somewhere in the price range of $2. So this is not a lot. So that was able to make him really happy, and it also made his mother happy that we were able to get him we were able to fix his fidget spinner. But for me, it was nice to be able to interact with him. But that began a very deep walk down a rabbit hole for me. I ended up spending a lot of time making different fidget spinners just for the purpose of using this as a way for me to learn 3D printing. It was a fairly innocuous thing to learn 3D printing. The next one I ended up making was this. This is, if you're not familiar with Adafruit.com, you really should be. They actually have a Thingiverse pattern with their logo as a printable. So I grabbed some blue filament, and what I like about this one is that I ended up using a fairly thin outer layer, and so you can see I had a fairly light infill, so there's not, you can see the little honeycomb pattern inside it. This one, it doesn't grip as tight. The other two that you saw, I actually had to take some time with my pocket knife and kind of continue carving out the inside to get the bearings to even fit in here. This one, it's much looser. I can easily, as you can push this, well, okay, fine. Now that I'm trying to say that, it's not going to pop out, but I can quickly push this in and out from here. The other challenge to this one, I'm not sure how well it's showing up on this camera, but the edges here are a little bit crazy. You can see on this side, if I get into the light, the layers are a little distorted. And the reason that I made the mistake, personally, what I did is I printed it upside down. That's the way the pattern just appeared within my slicing software, so I just left it that way. What I should have done was flipped it over. It printed this side up. So all of these layers, and it does taper, all these layers were starting from the smaller side and building their way out and up. So that's, I think, what caused some of it, as my particular printer doesn't have a heated bed, which means that it's sensitive to, the longer it takes to print, the printer bed will cool off and the filament will start to contract and pull away from the bed. And so I got all these different irregular lines from doing that. So I'm still learning with this one. I want to at some point go back and reprint this one, but I want to do it with the other side down, so that way I can see if having the layers when it comes up on the top, if that doesn't make it for a much smoother piece. Now the next one I went ahead and printed was this. I've always loved that Bohr's atomic model. And this one used smaller bearings, which I had to then order again. A 10-pack cost me $3. I think it was even less than that for this. I really like this one. In fact, one of the other things I liked about this, the other ones with the larger bearings, it's a little harder these bearings would pop in and pop out. If you weren't careful, they would stay in place. I didn't have any problem with these things staying in place, but when I went to put them down, they could pop out. With this one, these smaller bearings, they were held in fairly tightly, but just a simple little spin might send them flying if I wasn't careful. So these have been super glued into place. Now what's kind of funny about that is, when I was a kid, I had this book. In fact, I know that it's somewhere in the basement, but I'm not about to go looking for it. I started into that area and the thought horrified me, but I had this really great book that had these little paper cutout patterns. And what you did is you laid the patterns down on styrofoam containers. And if you're old enough to know this, there was a time not that long ago throughout the 80s when everything at McDonald's came in a styrofoam container. And so you take these, they told you then what meals, styrofoam containers, you would then lay these patterns down and cut out the styrofoam and then glue together with Probably should have used a different glue, but in our house, my dad was always handing me, great dad, my dad's always handing me super glue. So in retrospect, I mean, my fingers all separated out and everything, but I would use the super glue to put this in there. And I would only have any one of these planes that you could then fly for a very short amount of time before the glue actually ate the plastic. And I've started to notice it isn't as bad, but you can somewhat see that the area where the ball bearing meets the plastic has kind of become somewhat translucent and has actually started to spread out. And I had to clean off a lot of just this white goop, I don't know what else to call it, off of the particular bearings. Now, this one actually came out, by this point, by the time I made this one, I'd already developed some good techniques. I'd found different ways to adhere the print to the print bed, found various settings within my slicing software to make sure that it started off nice and slow. So I've taken some time to learn from my local makerspace as well as from the online community on how to make a good print. So this one came out, I'm really proud of the way this one ended up coming out. So in addition to this one, I ended up getting some glow-in-the-dark filament. I found two different types, one that glows in the dark blue, one that glows green. So this one, when the lights go off, and I just tried turning off the studio lights to be able to show this off, and it did not go like I planned. So we're going to leave the lights on this time. This one is glow-in-the-dark. It has that nice little radioactive do not touch sci-fi green when the lights go out. This one I haven't yet glued the bearings in. You can kind of see where the bearings fit. I can spin it pretty well without having any problems. If I spin it too hard, the ball bearings go flying. Doing that in a restaurant, as happened a couple weeks ago, not recommended. So I'm really proud of the way these two came out, and so from there I just decided I was going to try another one. I've got a simple Ninja Star. Both the Ninja Star and the Adafruit stars, they don't have outer weights. So these don't spin as hard or as fast as their weighted counterparts, but I still really have liked where these have been going. And then lastly, the one I want to show off is my little yin yang. Now, this particular one, completely impractical, but I wanted to try something a little more challenging. This one isn't one fidget spinner, it's two. It's not exactly the most cooperative when it comes in terms for spinning because it is completely irregular in its weight. As you can see, it's very clear which way it's going to tip when I do that. Now, what was an interesting challenge about this particular one, whereas with so many of the others, I've actually had to carve out extra space to put the bearings in. This one, the bearings just fall right through. So I've got these really horrible hot glue blobs. Luckily, they're not showing up as well on the camera as I was afraid they were going to. But also, I ended up making the choice to flip, because it's the exact same pattern, just done twice. And what I ended up doing was taking, from when I did the white one, I ended up flipping it so that way, for both total pieces, it's printing from the bottom up in the same direction. This is also, by the way, my first time. You'll notice all of my other ones, I haven't bothered putting in the middle piece. There are typically, with a lot of these fidget spinners, middle pieces that you can then have on either side that hide the skate bearings and give you something to put your fingers on. I just like holding onto the bearings themselves. It's a personal preference. So this one had a lot of challenges. It's somewhat visible on the camera here, just how irregular this is. They did not fit at all. I had to spend a lot of time with my pocket knife just kind of sanding down and filing down all those odd places, as well as the pockets that the tabs fit into. I had to shave out the excess little pieces in there to get it to fit. But in the end, I like it. It's not at all a practical fidget spinner for actual use. And I certainly can't do it with both hands. But it was just kind of a neat experiment to see how much I could do with that. Now, you might think that's great. Fidget spinners are a neat little toy and all. But what about doing something practical with 3D printing? So I've started my way up the practical approach. This is a neat little tiki guy that I printed This is the second attempt to make him. The first one I was making him in black, and it got up to here. Now, what's interesting is, as I mentioned, my print bed is 4 by 4 by 6. So I've got, this is taller than it is wide, and even he has a slightly lopsided base, but not nearly as bad as his first attempt, where the edges started cooling, and I was using what at the time was only there's a couple different things you can lay down ahead of the actual print itself. One that is called I can't even remember what it's called because I don't use it anymore. But the other one is called a raft, where it'll be a good couple of layers of 3D material that is printing back and forth in a crisscross pattern to create a surface on which to build. And it's usually just a slight variation of the bottom layers themselves, just a little wider out, so you have something to build on top of other than the print bed itself, and it gives it something for that material to hold on to. This one I was using the other, when I did it in black, I was using the other one, which is just one quiet little layer, just one layer of black ahead of time. And it got up to about here, and it started, because of the way it was cooling, it was just shimmying back and forth, and it suddenly detached from the print bed, and the print head was still up here and printing back. So I just had this black spaghetti mess with the piece somewhere off on the edge of the printer itself. So finally, I that's when I learned to start using some other printer techniques, and so this came somewhere in the middle of all of the other print jobs you've seen. So I'm really starting to like the way these prints are starting to come out. Another thing that I made, again, not extremely practical, there's this little guy. This is Makey. Makey is the mascot for the Maker Faire community, and I just made this little guy just to see if I could. But then the more practical thing that I made was this. It's two different pieces that hold together without having to do any screws. It's meant to be for a Raspberry Pi. So take a Pi Zero and place it here inside the case. Now I can close it up. I have access to the mini HDMI and my USB ports. Now this one also has space for you to attach a camera, run the camera around back, and come out through this hole here. And then the other two holes that you see, so that's where the camera would come out. And then the other two holes are intended for putting in little tabbed suction cups. So this is meant to be a security camera that you could then place against a window and then have the Pi inside it. Now, let me go back actually to the overhead camera. It may not be extremely clear, and now I've managed to jam this thing up pretty good, that this did not print at all well. You can see both pieces laid down, and brim, that by the way was the term. This is back when I was still using the brim, so it's only one little layer instead of using the full raft. And I attempted to use an early technique using a glue stick on my print bed to hold it, and all that ended up happening is it still ended up warping. You can still see how crazy it is. In fact, right now the brim is actually still on this. I could not separate the brim from the print. I just had to end up peeling off as much as I could and then filing it down. And this is horribly warped, and I'm not going to end up using it. But this shows off the idea of making something practical rather than just toys. The idea of being able to make something, rapid prototype, an enclosure for a project. The other technique that I still need to develop, so far, everything that you've seen here was downloaded from Thingiverse. So I wasn't actually doing any of this drawing in 3D space myself. That's a technique I still want to learn because I want to be more independent with my making or with my projects, that I can take a particular thing that I'm working on, a circuit board, and build a base for it. Another example of something practical, and I'm going to try pulling this over. This little box holds an Adafruit Trellis Kit. So it's a 4x4 flexible membrane with some LEDs on a circuit board underneath that create a little, a little 4x4 light up thing, and it's connected to what is it called? It's essentially an Arduino clone. And this one happens to be, it's a small little clone that can do keyboard. So that way I can use this along with my production software, so that this little map, I can map out each of my individual little shots to various keys and do it that way. So the idea of being able to use 3D printing to create practical objects, enclosures for part of my kits, really excites me, and I'm looking forward to doing more with this. Now, in the meantime, I wanted to talk about, going back to my fidget spinners, I've been seeing a lot more with this. There's been a lot more work being done, and what I find kind of cool is Instructables recently had a challenge to create fidget spinners yourself. Some of the cooler ones I've seen are using LEDs. This is similar to a project I wanted to work on, and I still have in my list. I want to do a persistence of vision spinner. This one uses an AT-Tiny, which is the Arduino's little brother. It only has 5 pins, so that's why he only has 5 LEDs in here. There's this one, which is really cool. It's a zeotrope, so as you spin it, you're looking inside and you can see a little animated picture. Done in wood, done with laser, done with marbles, all sorts of different styles. But then, to me, one of the coolest ones, Hackaday.com recently did a article using a fidget spinner for teaching STEAM, sometimes called STEM, but I agree with them on calling it STEAM. And what this particular project is, it has 8 LEDs, it has a microcontroller, it has a USB plug, and then a battery. And so what's really amazing to me about this particular one is that they're turning this into a learning launch point. Since kids are already playing with the fidget spinners anyway, why not give them something you can learn about it? Imagine putting onto there an accelerometer and other types of sensors so that young people can hook these up to a computer, add in additional code, have the LEDs like either as you're spinning it, the power up the lights and so forth. I really like where this particular project's going. STEM being, by the way, science, technology, engineering, arts, and math. And there's a huge debate in the community on whether or not it should be STEM or STEAM. The addition of arts has become somewhat controversial. I used to be on the other side of things where I thought it should just be STEM. But the more I see of the STEAM community and fusing that additional artistic ability and looking at some of the stuff that I'm making, this is clearly much more artistic than just engineering, and I really think this community is going someplace. So I'm going to have links to the fidget spinner you just saw for Steam, as well as all the fidget spinners that I've created. They're all on Thingiverse, and I'm going to have that original one that Elijah picked out, and hopefully you'll get something out of this. So this has been a major learning experience for me, trying to learn 3D printing and all the different mistakes I've made, from having things overly warped, just having overnight prints that at the last hour disconnected from the print bed and just created spaghetti all over the place. 3D printing is a very difficult skill to learn, at least it has been for me, and it's been a wonderful learning experience. So if you have any different projects that you've been working on, by all means, please reach out to us at Verbose Mode TV on Twitter. But additionally, you can find us on the web, Verbose Mode TV, Twitter at Verbose Mode TV, and then on YouTube, Verbose Mode TV. So if you're finding us on YouTube, write in the comments below. If you're finding us through the website, you can comment on the website. If you're just finding us, find us on Twitter and send us a message. What have you been 3D printing? What techniques have you found? What questions do you have about 3D printing? I'll also have the information, the link on my 3D printer. It was sub $300 printer. So while it may not be the biggest printer, it's been a great introductory printer for me to play with before I get involved in spending $600, $700, $1,000 on my next 3D printer and making bigger and better projects. We'll see you next time.